Hello everyone, my name is Phoenix, back with another video. In this video we are going to solve our next CTF challenge, which is delegate. As usual, I have copied this entire contract into my local environment, but first check what the objective of the CTF is. The objective of the CTF is to become the owner of the contract and to change this mapping for us to be true. Let us just quickly see what the smart contract is all about. We have some state variables. We have a state variable called owner, and then we have a mapping. We have an only owner modifier constructor, which is changing this variable to the calling address. We have a function called hackme. This function has the ability to delegate call to the given address. And then finally we have a function called hack, which is protected by only owner modifier. It is not checking, it is changing the state variable for the caller to true. Now, in order to exploit this contract, we need to understand what delegate call is. So in Solidity, there are three types of low level call: simple call, static call, and delegate call. To understand delegate call, imagine that you have two smart contracts. One is this, that is storing state variables, and another smart contract where you have the logic. If you want to find a way where you can change those state variables but you have to borrow the logic of the contract, you use delegate call. So to put it simply, delegate call basically works in the context of the caller, which means the logic will be of another contract but the variables change will be of the caller. So what we can do is, since delegate call is a very low level call, it also gives the ability to the next address to change the state variables of this contract, which is what we are exactly going to do. Before that, we need to figure out what will be the slots of this and this variables, because our main aim to attack this contract will be to delegate call to the attack contract and then change the state variables. So I've prepared an attack.sol contract. As you can see, the storage is quite similar. The fashion of storage is very similar in both of the contracts. What I'll do is I've created a function called pawn, which will delegate call to this contract only. As soon as this function gets executed, the call will be transferred to this contract where the fallback function will be executed. Here I will change both of these variables to owner and to whatever I want to set. Now let us just quickly jump to the solution. I have created this setup where I have basically deployed both of these contracts. The test attack function will first call this pawn function, and then if the hack has been successfully executed, we should be able to see that the state variable owner and this mapping should be changed for us. We cannot go to this route to basically execute the hack function because it is protected by only owner where this condition has been hard coded. So the only way to change this mapping is to change the state variable for us. Let us just quickly run the test. I'll type forge test. Perfect. As you can see, our test attack function has been successfully passed, which means both of our assertions of owner and mapping has been successfully executed. This brings the end to our video. Stay tuned. Have a nice day. Thank you.